Alright, this video we're going to create a systems of equation and we're going to do it from a set of tables. So here's two tables. If you notice the difference in the two is not just their numbers but the labeling of the columns. You got X and Y1 and the other one's X and Y2. So what we're going to do is we're going to create, I would like to put these in these tables. I want to change these tables into the slope-intercept form. So I'm going to put these in y equals mx plus b form. We're going to do both of them. Same thing. So the first thing we need is the slope. We need to find the slope, and that's what m represents. So the slope is m. And the b is going to be my y-intercept. Remember, the y-intercept is when x equals 0. Now, I created this one for a particular reason because sometimes this happens quite a bit often, and so it's kind of easy to find it. Now, remember, the y-intercept is when x equals 0. And if you look right here, you have x is 0. And then on the other table, too, you have the x of 0 there. So right there is our y-intercepts right there for both equations. And so when x is 0, we want the y answer. And you can see on the first table it's 3, and on the second table it's -2. So the only thing we really got to find is the is the slope. So we're going to find the slope for each one of these. And if you remember the slope formula, and I'm going to do them each side, the slope formula is y2 minus y1 over x2 minus x1. Alright, and so we're going to pick another point, and I'm going to pick them, I'm going to put them in a different color here. I think I'll use the 0, 3 and the -2, 9, use 2, 9 here. Alright, so this is my y1. It doesn't matter which one we call y1 or y2. We'll say this is my y2. We're going to go ahead and say that this is my x1 because I use the same y1, and this is my x2. So I'm going to plug in my numbers. So my y2 is a 9. And so we have minus, and my y1 is a 3. Remember, we're working right here with these guys. Alright, and then the x2 is going to be 2, and we have a minus. So don't forget, we're getting these minuses from our formula. -2, and our x1 is a 0. So if we look at this, 9 minus 3 is going to be 6 over 2. And so 6 over 2 is going to be 3. So my slope is 3. So if you remember, we already have our equation here. We can say it's y equals, my slope is 3, so it's 3x. My y-intercept is also 3. And I got that because my y-intercept is up here. So there is my one equation in slope-intercept form. Now I'm going to do the other equation. And we're going to use the same process. We're going to use the slope. And we're going to say y2 minus y1 over x2 minus x1. And again, I'm going to pick out my point. I'm going to use the same thing I did before. I'm going to just pick one right below. It doesn't matter. We can pick any. And I'm going to use the y-intercept because since that's the y-intercept, we'll just use it. It helps us out. We'll say this is, I put x by accident. This is y1. I'm going to say this is y2. I'm going to use this as x1, and this is going to be x2. Alright, so I'm going to plug in my slope information. And so my y2 is a -2. Oh, sorry. My y2 is a -6. And then we have a subtract sign. And I've got to be careful here, and I'm going to go ahead and put it in a different color. The red, the y2 or y1 that's in red, that's a -2. And so you notice I have two negatives right here. See those two negatives? That's going to change to a positive, so we'll fix that here in a second. Alright, and then my x2 is going to be 2 minus 0. So I'm going to clean this up a little bit so you can kind of see it. So I'm going to rewrite it so you can see it. It makes it look. So it's going to be negative 6. Oh, I want to change that different color I said. Negative 6, and like I said, the two negatives here, they're going to make a positive, so it's going to be positive 2, and negative 2 minus 0 is 2. So it's going to be negative 6 plus 2, so hopefully you'd use your calculator. That'll make negative 4 over 2. And if we were to reduce this, our slope, or simplify this, our slope would be negative 2. Alright, and again, we're going to do the same thing we did with the other one. We're just going to put it in slope-intercept form, So we have y, and we already know our slope's negative 2, and that's in front of x. And our y-intercept, like we said earlier, is right here in the red. It's negative 2. Alright, so we have, and I'm cloud them. This is our cloud. These are our y-intercepts. Both of these guys are our y-intercepts. And we could graph these on our systems equation, and it will show us where the solution is. It tells you either where they intersect, or if they're the same line, parallel, or just like we discussed before. So this is the slope-intercept form. Alright, but I want to go a little step further. I'm going to go ahead and change them into standard form. So I'm going to change these to standard form so you can kind of see what that would look like in case they ask it. So here are the two problems. We had y equals 3x plus 3. And the other one was, for table 2, was y equals a negative 2x minus 2. And see, we can go back and look at them. See, they're both 2x minus 2 and 3x plus 3, so it worked out pretty good for us. Alright, so now we're just going to change these into standard form. And remember, standard form is ax plus by equals c. So we just want to put our x and y together on the same side of the equal sign. So let's start with the table 1. And this is table 1, really. Alright, and so we're going to move our 3x over. So the opposite of positive 3x is minus 3x to both sides of the equal sign. This will give me a minus 3x. Now remember, our y is positive, so we're just going to say plus y equals 3. Now remember, we said a can't be a negative. It can't be a fraction or a negative. So to do this, we technically would multiply everything by negative 1. We could divide everything by negative 1. But like we talk in class, we really just change the signs. So instead of a negative 3x, we're going to make it a positive 3x. Instead of a plus y, we're going to say a minus y. Instead of a plus 3, we're going to say minus 3. And that right there will be one of our equations. Alright, so let's go back over here. Alright, and we're going to do the same thing here. We're going to add 2x to both sides because we're trying to get the x and y on the same side of the equal sign. So now we have 2x plus y equals a negative 2. My a value, which is right here, is not negative nor a fraction, so we can leave it like this. So this is our other equation. So these two, and I'm going to write them in red so you can see it, we have 3x minus y equals a negative 3, and we have 2x plus y equals a negative 2. These two both are two equations. They have two variables, just like we talked about earlier. And so these are systems of equations.